My name is Arthur Edelstein, and I work for the Tor Project on Tor Browser. And today I'm going to talk about the fight for privacy on the web and how we are trying to improve web privacy with Tor Browser. Why do we care about web privacy? Well, the simple reason is that the web has become one of the most important ways that human beings interact with the world. And unfortunately, the web has created opportunities for abuse. Governments and corporations are monitoring your internet use, and they know what you search for and what you read. And they can block you from reading certain things, and they can promote other messages that are tailored specifically to shape your view of the world. And governments are seeing opportunities through this spying for mass influence and mass oppression. And corporations also see opportunities to try to shape your life, the culture of your society, and even your own psyche for their profit. And they're monitoring billions of people because they can and because it benefits them. So these governments and corporations are seizing an opportunity for centralized control of the experience of the whole online population. And it's not hard to see why this is a huge danger to democracy, to freedom of expression, to freedom of thought, and other human rights. So it's essential that we look for ways to try to reverse this centralization of power. So there are many approaches to fighting this kind of oppression, but one of the approaches is a technical approach. So the problem we have to solve is how do we make the experience of the web still great, but respect the privacy and the rights of users? And the solution, or one of the solutions, is fairly obvious, that we need web browsers to operate on the user's behalf, not on behalf of advertisers or ISPs or government spies. So if web browser makers really want to claim that they respect privacy, then they need to stop the bleeding, stop the leaking of our private data. So at the Tor Project, we're trying to set the example of how a web browser can responsibly protect its users. We're a small nonprofit, and it's an ongoing struggle to provide the kind of online privacy and security that is the right of every person. But we hope our example will be adopted by big web browsers eventually, browsers such as Firefox, Chrome, Safari, Edge, etc. So I'm going to talk about some parts of our work, some parts of our approach in Tor Browser. First, I'll just give you a short introduction to what Tor Browser is, how you download it, and how you use it. Then I'm going to talk about how the Tor network works to prevent ISP and server logging, how it prevents your IP address from being logged. Then I'm going to talk about how Tor Browser stops super cookies from being used to track you. And finally, I'll talk about how Tor Browser hides your online fingerprint, your browser fingerprint. And I'm going to talk about, after that, how we can scale up some of these approaches. So downloading Tor Browser is easy. It's just like a browser. You can go to torproject.org and click on the Download Tor button. That takes you to a page which gives you the option to choose the language you prefer. We currently support about 16 languages for Tor Browser so that people all over the world can use it. And once you open Tor Browser, this is the first welcome page you see. And I'm going to switch to Tor Browser so I can demonstrate what that looks like. So this says, welcome to Tor Browser. That's the first page that you see when you start up Tor Browser. There's actually a step before that, which I didn't show, which is a wizard that helps you connect to the Tor network, but I'm going to skip that for now. So if we click on Test Tor Network Settings, then the page it goes to confirms that we are using the Tor network, and the IP address that the server check.torproject.org sees is not my IP address. It's an IP address of a node in the Tor network. And if you look up here, this is the Tor button. And on the right here, there's a little window that says Tor circuit for this site. And it shows a series of 5 nodes. The first node is the client, that's our web browser here. The second node is a Tor relay somewhere in the United States. The next node is a relay in France. The next node is another relay in France. And finally, the last node in this series is the web server that we're connecting to. So let me try to explain what that refers to. I'm just trying to find my slideshow again here. So this is a diagram from the Tor website that shows how the Tor network can hide your identity. And it's a very clever design. There are thousands of Tor nodes relays around the world. And if my name is Alice and I'm trying to connect to bob.com, let's say, the first step is that my client obtains a list of all the Tor nodes and their IP addresses. The second step is that my web browser will pick 3 randomly chosen nodes in the Tor network and form a circuit that is a connection that communicates all the way from me through those 3 nodes to the Bob server. So that would be if I wanted to visit a website that was on Bob's server here. If I want to visit a different website, I can choose 3 different random Tor nodes and connect to jane.com instead. And part of the design is that each connection between 2 nodes is encrypted. So when I first make a connection to the first relay, that's encrypted. When I make another connection to the second relay, now there are 2 layers of encryption. One layer is the encryption between the first relay and the second relay, and the other layer of encryption inside that goes from Alice to the second node. And you continue to layer on layers of encryption. And so this is called onion routing, and that's where Tor gets its name, because it stood for the onion router. So this is the way that the Tor network is hiding your IP address from anybody logging, for example, at your ISP. It's really providing a couple of services. One is that it makes it look like your IP address is the exit node. So if a server is logging connections, it's going to be logging the IP address of the exit node, not of the person browsing the web. And because we have an encrypted connection between the first relay and the web browser, it's not possible for the ISP to log your internet requests either. So that's the first part of how Tor browser protects your identity, by using the Tor proxy and the Tor network. But unfortunately, hiding your IP address is not enough to stop corporations or governments from tracking you. Unfortunately, there's also other methods that are enabled by the modern web that makes it very easy to track you as you browse online. So the first one, which is very well known, is called cookies. So let me just quickly explain what cookies are. If you visit facebook.com or any other website, it can send a short piece of data to your browser accompanied by a set cookie command. So this is the only code I'll show, but this is set cookie, username equals Arthur. The cookie is username equals Arthur, and set cookie is the command being sent to your browser. So now the cookie is stored by your browser because your web browser is complying with the standard web specification for cookies. So it's stored by your browser in the cookie database, and it's filed under the origin, let's say facebook.com, because facebook.com is what set the cookie in the first place. So here we have your cookies database, and under the facebook.com key, we have username equals Arthur. So later, if you visit facebook.com again, the browser will retrieve all cookies under that origin and send them back to the server automatically. It sends this header, cookie username equals Arthur. So you can see, here's a little demonstration. If I visit Facebook, it'll set the cookie in my database to username equals Arthur. And then if I visit Facebook again a week later, then the cookie is sent back to Facebook so it knows who I am. And there are legitimate uses for this sort of thing. For example, it can keep you logged in to Facebook. But the problem with that is that the cookies are much more powerful because they can be used by third parties. So let's take an example where I've logged into Facebook as before, and it's saved the cookie username equals Arthur. Then let's say I visit CNN, and you'll notice on CNN there's a Facebook button. And it turns out this Facebook button contains a script, and it's setting a cookie or reading cookies. And so it can read the cookie stored under the facebook.com domain. And now Facebook knows that I've been reading this page on CNN about flying motorbikes. So how do we solve this problem? Because now because Facebook buttons are extremely popular, Facebook can monitor everything you're reading on many websites. So the solution that the Tor project developed is called first-party isolation of cookies. And the idea is this, that if you have a first-party domain of CNN.com, the first-party domain is the domain that you see in the address bar at the top of the browser, and you have a third party like facebook.com attempting to set a cookie, you can combine these two domains into a double key. We'll call it cnn.com bar facebook.com. So we use this key in the cookie database. So let's look at how this works. So under facebook.com, if it sets a cookie directly, a first-party cookie, we have the first party, facebook.com, and then the origin of the cookie is the same. So it's facebook.com, facebook.com, and it saves username equals Arthur. But now if I visit CNN, in the cookie database, we have the double key cnn.com, facebook.com, and now it's unable to read the cookie that was set when facebook.com was the first party because it's under a different double key. And so it does not get a username back. So this is how to solve the problem for cookies. Unfortunately, there are many, many other ways of storing state in the browser. And so we have one of the generic names for this is super cookies. So apart from cookies, there are various databases maintained by the browser that store all kinds of information persistently. And also for networking purposes, there are many other pieces of persistent state. But it turns out that the double key, those are super cookies, turns out that the double key method is a good way of stopping all kinds of super cookies. So basically, instead of only keying all of those things by origin, which is what is typically done, we always include the first party domain. And so we isolate, whether it's the web cache or something else, we always isolate that by first party. So a first party a.com cannot read anything or write to anything that, it cannot read anything that was written by b.com, or the first party b.com. So that's the second technology that the Tor project developed to try to fight tracking. The third technology is called browser fingerprinting. Sorry, that's an attack. It's browser fingerprinting protection is the third technology that the Tor project is developing. So JavaScript and CSS on any web page are allowed to extract numerous characteristics of your computer hardware, your browser, and your operating system to distinguish you from other users. And these characteristics in combination are termed your browser fingerprint. And the fingerprint can persist over days, weeks, or months and be used by tracking scripts to follow you as you browse to different sites. So I'm going to show a quick example here. So if I go to browserleaks.com, and I'm going to go to the font fingerprinting section. Down here, there's a JavaScript trick that allows browserleaks.com to get the full list of the fonts that are installed on your system. And as you can see, we've got a lot of fonts installed here. And this is a very good way of distinguishing users, because anytime you install a font, that will be added to this list, and that can be detected by any web page that has the fingerprinting script embedded in it. But in Tor Browser, I can run this again, we impose a whitelist or a restricted list of allowed fonts. And it's a short list. Among the fonts in the list, 19 of them are detected by browserleaks.com. And these fonts, these are all system fonts that are included by default in Windows, but we don't allow any other non-default fonts to be used in the browser, and that prevents browserleaks.com from detecting it. And so this gives us a more or less homogeneous font list for all Windows users. So that's just one example of how we've been working on fighting browser fingerprinting. It turns out there are many, many fingerprinting vectors, and each fingerprinting attack requires a different protection. So in some cases, we spoof values so that when the browser wants to know the screen size, we don't return the screen size. Instead, we return the window size. In other cases, we block the value altogether, so we just don't allow certain web API calls to be made by scripts. So those are the three anti-tracking protections that I'm talking about today. And this shows the current situation. We have about something like 2.5 million daily Tor browser users. But that's a very small fraction of the total number of internet users. There's something on the order of 3 billion internet users worldwide. And many of those users are using something called private browsing mode. You may be familiar with it from Firefox or Incognito mode in Chrome. There was a recent survey by DuckDuckGo, and they concluded that nearly half of people had used private browsing mode at some point. So what is private browsing mode exactly? Well, in Firefox, if you go to the File menu and click on New Private Window, you get a window that looks like this. And it says Private Browsing with Tracking Protection. And it points out that it doesn't save cookies, which is a good thing. But at the bottom, there's an extra disclaimer that's very important to read. It says private browsing doesn't make you anonymous on the internet. Your employer or internet service provider can still know what page you visit. So you have to look carefully for that message. Incognito mode is very similar in Chrome. And they say down here, if you read it, your activity might still be visible to websites you visit, your employer or school, or your internet service provider. Might still be visible is too weak, in my opinion. Your activity almost certainly will be visible to at least one of these. So what's interesting is that in this DuckDuckGo study, they found that 2/3 of people overestimate the protections that they get from private browsing mode. So even though there are these warnings here, apparently they're not enough to protect people from assuming that private browsing mode is stronger than it really is. Some of the top misconceptions are 40% of people believe that private browsing prevents websites from tracking me, and almost the same number believe that private browsing prevents ads from tracking me. But we know this isn't true because the sorts of protections the Tor browser is providing are not provided in private browsing mode. So it is true that private browsing mode avoids saving your web history, but it does not protect against most super cookies. It does not protect you against fingerprinting. It does not hide your IP address from websites. And it does not hide the list of all sites you visit from your ISP or a VPN if you're using one. So I would argue that private browsing windows are simply not private, and incognito windows are not incognito. And I think that's really important, that if we're going to be protecting people, and we shouldn't be, if we're going to protect their privacy, then we should be actually trying to fulfill their expectations. So what do we do for those billion users? I think we should fix private browsing mode in all browsers. So how do we scale up from tiny Tor browser to the major web browsers? So the first stage is that we need to keep improving Tor browser to protect users and use that to demonstrate that browsers can do much more to protect users' privacy. The next step, which we're already doing, is to work with Mozilla to uplift all of Tor's privacy features into Firefox private browsing mode. And when Mozilla has determined that the features are polished enough, they can automatically deliver the new privacy features to existing Firefox users. And once users become aware of these new privacy features, then Mozilla can differentiate their browser from the other browsers because they're actually respecting privacy. And so I hope that having seized this opportunity of improving privacy, Tor and Mozilla can propose new standards that all web browsers and the web should follow to protect user privacy, so it becomes the norm. So what are we doing to continuously improve Tor browser? We're working closely with Mozilla on many kinds of patches. We're going to start a project to make mobile Tor browser as fully featured as desktop Tor browser. We're working on user experience, performance, security, and of course, we continue to work on privacy. So I think it's important to always remember that engineering can't ignore ethics. Technology is not neutral, and we should say what we mean. When we claim to provide a private browsing mode, it should do what it says. It should make users private, and it should make their web browsing private. And I think we made a big mistake in not building privacy into the web in the first place, but I believe that we can fix that mistake. So I'd like to thank everybody on the Tor browser team, also the Guardian project, and I'd particularly like to thank several engineers on the Mozilla team, Jonathan Hao, Tim Wong, Chengsheng Fu, Tom Ritter, and Ethan Tseng, and Yoshi Wang, who have been upstreaming our patches to Firefox. I'd also like to thank everybody on the Tor project and our funders and you. If you want any more information, you can visit torproject.org, and you can read also a very interesting document, the design and implementation of the Tor browser. So that's it, and I would love to hear questions. Okay, Tom asked, which browser is most vulnerable? That's a difficult question. I think they're all, in terms of privacy, I think they're all highly vulnerable. It's very easy to track people. In terms of security, there's much more effort has gone into security in various web browsers, but I'm not familiar with all the differences enough to say which is the best. And And the next person asks, what advice do you have for organizations that are struggling to keep users' information private? Well, I would advise people to consider the various web browsers and look at which is protecting their privacy the best. And I'd also encourage people to use Signal for messaging. And the next question from Cinnamon is, are there any popular vulnerabilities that still exist using Tor Browser? Well, whenever there is a security vulnerability, we immediately, when we're informed by Mozilla or by somebody else, we immediately patch that vulnerability and release a new version of Tor Browser. There are definitely improvements in our privacy protections that we are still working on. One improvement has to do with window size. Right now, when a new window is opened, it's fixed to a particular size to protect your privacy, but we'd like to make that more usable than it currently is. Cinnamon asks, what are big challenges for Tor Browser? One of the big challenges we are working on is to try to improve security, to try to harden the browser against exploits. And we've been taking various approaches, including adding compiler flags that harden the binaries, and also we're working on trying to improve sandboxing of the browser. But we have a lot of work ahead of us. What industries should worry the most about their privacy being compromised? That's tough. I mean, I think all industries need to worry about it to a degree, but it's a very complex question. Certainly one of the fields that's very near and dear to my heart is the human rights activism, and I think people in that kind of work really need to be very serious about their privacy. Yeah, so the Guardian project has been developing a browser called Firefox, which is based on Tor browser patches, but building the mobile version. And actually, we're going to use that as the basis for a Tor browser mobile version. In the next several months, we'll be starting up that effort. So thanks again, everybody. I enjoyed this a lot. Take care.